Good morning. Welcome to Building a Windows Store application, video application session. My name is Cenk Dingiloğlu. I'm a program manager in Windows Azure Media Services team. So who is familiar with the media services? A few people, okay. Who is familiar with building video applications for Windows stores? Very few. Okay, this is a good session for getting some insights and details and begin with using the media services and building applications. In today's session, I will be briefly going on what is changed for media industry and also mentioning on the cloud video technologies like Windows Azure Media Services and how to consume the cloud-powered videos using the Windows endpoints. So what changed the media industry? I believe probably all of you are watching online videos and consuming a lot of your time watching the videos. So according to a latest study, 100 million households includes at least one connected TV. The smartphone market is growing, it is 50%, and the tablet market is also growing and it's an emerging market. People like multitasking. They watch TV when they are doing other things. And as a prediction, by 2016, 10 billion mobile connected devices will be in the market. So online video is a hot topic for today, and it will be a hot topic in the future. To reach this kind of devices, multiple devices, a lot of formats, and different technologies, the Azure Media Services come with a philosophy. The philosophy is high-quality videos for any device, anywhere, and anytime. So this includes three pillars. Format agnostic, because different devices support different formats. And the second is the protocol. Different devices support different protocols and different DRMs. So when we combine these together, the ultimate philosophy is reaching any endpoint with best possible format, protocol, and DRM. So before going to the details of the Azure Media Services and the player application, I just want to briefly mention about the media delivery methods. So the first one is the progressive download. Progressive download, you have a single file. The client connects it over HTTP or other protocols and downloads it to the client and begins playing in the client side. So the other is the traditional streaming. It is the legacy streaming. Client connects to the server and sends a play, seek, pause commands, and the server responds back to the client with the packages it needs. These are traditional streaming solutions, which only includes single bitrate and single quality streaming. In today's world, the devices are changing and the needs are changing. So the mostly used and emerging technology is the adaptive streaming. So in adaptive streaming, you can have multiple qualities sitting on your server. And these are virtually divided into pieces, which we call fragments or chunks. When a client first loads the asset, it's a manifest, which includes the qualities. So the client downloads the manifest and it says, okay, I have in this example, it has three qualities, and selects the proper one for it and begins to request the pieces of the video over HTTP. It doesn't download the complete video because over time, actually it is 1 to 2 seconds, it calculates the bandwidth and the CPU of the itself and dynamically adjusts the quality. So begins with the 720p, and since these pieces are over HTTP and cacheable, highly cacheable, any commercial cache or proxy can cache the pieces for other consumptions. So it begins with the 720p, and over time, when it calculates the bandwidth, if it sees it can bump the quality into higher bit rates, it can increase the quality to, as an example, to 720p quality. So these are cacheable in the caches. When a different client connects, it can directly get it from the cache servers. So it makes the adaptive streaming technology over HTTP a highly scalable and also dynamically adjustable protocol. Microsoft's solution for adaptive bitrate technology is called smooth streaming. So there's other formats from other vendors, but the mostly used and combined protocol with the DRM is the smooth streaming. So media services team, as media services team, we provide a couple of frameworks to reach different endpoints using the smooth streaming technology. We can divide them to three main categories. The web players. These are traditional browser applications using the Silverlight, Flash, or native HTML5. The native HTML5 currently doesn't support this kind of adaptive bitrate technologies, but W3C includes a specification which is called media server extensions and the encrypted media source extensions to enable the adaptive bitrate in modern browsers. So for Silverlight and Flash, we have the smooth streaming clients, SDKs, and also the player frameworks, which I will be mentioning in the following slides. So the second category is the applications. Windows Store applications, Xbox applications, TVs, set-top boxes. And the last one is the mobile world. Windows Phone, Android, and the iOS. As media services team, we don't provide directly an Android SDK, but our partners provide these SDKs for consuming smooth streaming and play ready on Android devices. Also, people, you have the option to build an Air application using the OSMF plugin. So you can build the Android Air application and use the smooth streaming inside your application. This is the primary format for smooth. And in future, the Impact Dash is in our roadmap. We will be including the Impact Dash support in our SDKs. How many are you familiar with the Impact Dash? Couple of. So Impact Dash is a standard way of consuming adaptive bitrate technology. So I will be mentioning about briefly on the Impact Dash technology as well. But in today's talk, I will be primarily focusing on the Windows Store applications. Before going to the store applications, I want to cover the media services architecture. Media services, the Azure Media Services, is a platform as a service built on top of the Azure cloud platform. Windows Azure provides the infrastructure, storage, and the compute services. And media services is built over the top of this infrastructure as a platform as a service, which includes REST layer APIs and other programmatic ways to interact with the service. You can think about it as a highly extensible and configurable media pipeline. It includes, by default, Microsoft-provided components like encoder, packager, and also have the ability to interact with the third parties. Third parties can use the APIs and build their encoders or other media processors and include these in the pipeline. The orange boxes are currently generally available features. The on-demand streaming, encoding, packaging, and the black boxes are coming features, live streaming, identity, analytics, and advertisement. The advertisement, I want to clarify it, it is the backend of ad servers. The client side, I will be going over and demoing the client side. So using the REST APIs, people or customers or partners can build highly customizable media solutions. My colleague Ming-Fei will be covering details of these REST APIs and how to consume the media services using a programmatic way in today's building an end-to-end media solution using media services. So when you produce the content, you have the chance to stream it. You can use the origin services directly or offload your content to Azure CDN or partner CDNs. This is up to you. It is highly configurable and have multiple options. So you can select Azure services or partner services. As I mentioned before, we have a couple of clients to target this content, including Windows, Xbox, iOS, Android, and Flash, and Windows phones. So I want to briefly cover how the portal works. Actually, the REST APIs allows interact with programmatically, and the Azure portal also use these APIs to give a web-based management option. So let's log into Azure portal. So this is the general summary of the Azure services. It is not dedicated to media services. It includes all Azure services. In my account, I have some storage accounts, virtual machines, and media services. In the left side, when I click to media services, you can see multiple media services accounts. We give this ability because people can create multiple media accounts and target it to different data centers all over the world. Currently, we are running in 6 data centers globally. If you want to create a new one, it is very easy. Just create the media services, quick create, name it, and select your data center and the storage account. All files uploaded and converted are stored in Azure Blob Storage. So I will not go deep dive in this section, but I will be using the pre-created one for this session. So when you go to the first screen, you can get some sample codes to upload your video or download the SDKs for different languages, program languages. Let's go over a basic upload and encode section. So I will be uploading a content, then encode it to multiple bit rates and adopt smooth streaming technology, and will consume it inside my application. And also show how to dynamically package this single format to different formats. Let's select this MP4 file. It's a single quality, single asset. When I click upload, the service actually is uploading the file to Azure Blobs. Okay, my file is here. So it is not published yet. This means you cannot reach the file from public world. So you cannot stream it. Before publishing it, I will also convert it to smooth streaming format, which I can use dynamically in my application. So I will be creating a job. There are some presets for different endpoints. You can select these presets, or also the portal doesn't allow, but the programmatic way allows you to create your own preset as well. So I will be going with the smooth streaming 1080p and kicking the job. So this simple action also creates a job underneath in the Azure tasks. So after the task is created, actually the Azure encoder servers gets the job and begins to encode it to multiple bit rates, which is at the end, you will be getting a smooth asset. So my encoding task just begin. It will take a couple of minutes. When waiting for it to finish, let's go on the next section. So as you see, it is very simple to produce an asset. And you can select multiple presets to convert your video. But let's see how we can reach to stream this content to Windows endpoints. So in Windows, you have two primary ways to stream the content. One is the browser. The other is the store applications. For browsers, you have actually Windows provides two different browsers. One is the modern browser, and the other one is the desktop. For both of them, you can use the HTML5 video tag to consume content. HTML video tag allows you progressively download and consume the video. And also the current browser, the IE, supports Flash runtime. So you can use the Flash applications to consume the content. The last one is the Silverlight. Only the desktop IE supports the Silverlight. You cannot use the Silverlight in modern IE. So the store applications allows you to convert your Silverlight applications to consume inside the store. So the store gives the ability to build two kinds of applications, HTML5 and JavaScript, and C# XAML. So if you have an existing Silverlight application which is built using the XAML, you can easily port your application to store applications. By default, as I mentioned, the video tag or the media element doesn't support smooth streaming. So you need to add an extension to the media pipeline, which enables consuming smooth streaming in the video tag and the media elements. So what smooth streaming extension provides? Actually, the smooth streaming is the primary media delivery format for Windows. Our partners see, when we look at the store video applications, nearly 60–70% of the applications consume smooth streaming. So it is the primary format. It enables you to build use the SDK in all the supported languages, store application languages, including HTML5 and XAML. So you can use the SDK to build HTML5 applications and XAML applications. And it gives the ability to port existing applications, monetize applications with ad support, and begin easily programming and building an application with VS templates and player frameworks. In a typical application, we have 5 different layers: the platform, Windows, the pipeline, media pipeline, the smooth streaming extension SDK, and the player framework. Then you can build your application over the top of the player framework. So what is player frame? How the smooth streaming extension works? If you use a traditional MP4 file and set it to the source for video element, it will be resolved by the media pipeline, the media engine, and it begins to play back it directly. Decodes, renders, and decrypts if it is DRM encrypted, and the application and the media element interacts over the media foundation interface. When you put a smooth asset, typically it includes /manifest. The pipeline doesn't resolve it directly. So it lookups it is byte stream extensions or supported extensions. When it checks the extensions, it finds smooth streaming extension SDK maps to this kind of assets and begin using this extension and consumes the data. So how player frameworks helps to build rich applications. Player frameworks are open source components. So you can download it from the Codeplex and get the source code from GitHub and customize it for your needs. Actually, it has a lot of rich features out of box, so you can easily use it without any customization as well. It uses the smooth streaming underneath the client SDKs, which are low-level APIs, and it is shipped in different formats and for different endpoints, including store applications, HTML player frameworks, and Silverlight and Fawn player frameworks. It's a well-established framework. It is, I think, 95% of the existing applications use player framework underneath. So it is well tested and highly customizable. When we look at the player framework architecture, it is in the top of the layers. So you have the platform. It can be Windows, Linux, or other platforms. You have the media pipeline. A typical media pipeline is Media Foundation and the GStreamer. And you have the client SDKs, then the player framework. Player framework gives the ability to consume this kind of features very easily. Closed captions, strict play, offline playback, advertisement, smooth streaming on demand and live, multiple audio switching, DVR control. So I will be focusing on and showing you a very basic application which we can build with the player framework. Let's check our job. Actually, it is finished. So I have a single bitrate MP4, and I have a multi-bitrate smooth streaming asset. So I need to publish them before using. So it will give me a streaming URL. And let's publish. Before going to these details on the application, let's see how this sits in the blob storage. So this is my blob explorer. Okay. This is my single asset file which I uploaded first. It is the MP4 file. And when we look at the converted one, as you see, we have a couple of different qualities. The media services encoder get the single asset and convert it to multiple bitrates. So we can use it in our application. Before beginning to develop your application, you need to download the Smooth Streaming Client SDK and also the player framework. A new version is just released for Windows 8, and in a couple of days, a new version for 8.1, Windows 8.1 will be released. So you can use the existing Windows 8 version for 8.1 as well, but a new version which gets the new benefits of the Windows 8.1 platform will be released in a couple of days. So after downloading this, I will be creating a new JavaScript project. Let's name it build demo. You will get an HTML and a JavaScript, and it includes some CSS files. This is the skeleton of the JavaScript applications. So to use the player framework, I just need to go to references and add the player framework. So this is a known bug, but it doesn't affect the functionality. So after adding this player framework, I can just begin adding my basic reference. So 2 lines of code actually gives initialize the player framework, and also give the template of the video player. This is a highly configurable and customizable framework. So you can choose a couple of existing styles, or you can also create your own style and use it as a player style. The JavaScript initializes the player framework, and on the HTML side, I will just only need to add my basic player reference. So I use the code snippets to make it much more fast, but it is, as you see, it is very easy. A couple of lines of code and you can get the player. So what happens in the data wing controls? Actually, this is a child of the video element. So if you include the video element, the player framework will be a child of the video element. But if you don't include, the player framework will create a video element underneath. So let's go and get our MP4 file. Put it as a source. Okay, this is the, and then compile.
Why don't you just admit that you're freaked out by my robot?
As you see, it is very easy. So this is the MP4 asset. If you want to use it with the smooth, you need to add a couple of references. Add the Analytics Adaptive Streaming plugin. Okay. And the Smooth Streaming Client SDK and the C++ runtime. As you see, when you add the Smooth Streaming Client SDK and Visual C++, there we got a warning. We are getting this warning because the SDK is a native C++ component, so you need to target your built environment to get rid of this warning. When I change it to x64, the warnings are gone and I can use the SDK. So we have an adaptive, the player framework has an adaptive streaming plugin. To use the smooth, I need to first initialize this plugin. So as you see, it is a just single line of code which initializes, a JavaScript which initializes the plugin. And then we can go and add our smooth player. It is the same as the MP4. Just a couple of other properties to make it easy. And when I copy my smooth asset, just copy paste it.
Why don't you just admit that you're freaked out by my robot hand?
As you see, there's a signal indicator. It is right now the bandwidth is very high here and it is top, but in low bandwidth environments, you will see the signal decrease and the quality decrease. So these are the basics. So if you want to add a couple of different options like captions, just go and add the caption reference, which is the time text plugin. This. So this is my main content, a smooth content, and I have two tracks of captions. One is the English and the other one is the Spanish. When you compile it, so very quickly you can add the captions to your applications. Can change the captions, close them. Also, if your smooth streaming application includes multiple audio, you can easily switch the audios using the audio. Or director's commentary. So, how many are you thinking live streaming is a difficult topic over cloud? Cool. Actually, it is not released yet. It is in our roadmap as media services. And we will be announcing our live streaming support over Azure in a couple of months. But using the same player framework and changing only the manifest, I will be putting a manifest, you can easily stream the live streams. Let's see. So a couple of us are in the spot. Before beginning the session, I set up a laptop here, which is capturing this area. And it is pumping the data to the Azure cloud. Then my application is going to the cloud using the same smooth manifest and then streaming it to here over the Azure Media Services Cloud. This feature will be coming and will be announced in future. So moving forward, this is the basic applications. So you can create a progressive download application. You can use Smooth, add captions, add multi-audio, and also consume live streaming using the player framework. When you want to make money and include monetization and advertisement to your player frameworks or video applications, the player framework supports multiple formats. It supports VEST, VPaid, VMAP, and also supports the Freewheel, which is a major ad platform. Before going to this demo, I will just want to mention about a couple of different ad formats, the advertisement definitions. So mostly used video advertisement is the linear ads, which captures the all video playback and doesn't allow you to skip or go to the main content without watching the advertisement. I know most of you hate it, but this is the primary money making for the content owners. So it will get the playback, show an ad before, in the middle, and at the end. The non-linear ads are mostly doesn't captures and get the player control. They work and displays together with the main content and the advertisement. It can be a banner or an overlay. The third category is the companion ads. So it can be a combination of linear and non-linear ads, but it is generally a banner which is statically showing it in the video player. So in today's demo, I will be focusing on the VEST, which is the video ad serving template. It tells the video player what to play and also recommended by the Internet Advertisement Bureau. It's based on XML definition. You can define your advertisement schedule inside the XML. It is supported by the majority of the ad servers and also supports different ad formats, including linear ads, non-linear ads, and podcasts, and companion ads. So when we look at the definition, it is just a simple XML. It shows which ad server is served this VEST file, when you click, where the link will goes, what is the impression. And a typical data looks like this. So you have the video file, which is the .wmb. This will be playbacked. So when we go and demo this very quickly, so I uploaded 2 different VEST files to the Azure blob. So they are sitting in the Azure Cloud Services. You can control the content of this. So when we look at one of them, let's Let's open it with the IE. So the ad is 32 seconds, and it has this kind of bit rates, couple of different contents for different bit rates, and also includes the click URLs, the tracking URL and the click URL. When you go to the player framework, it is just as simple as adding the smooth feature. Just go add the advertisement plugin to the references, create the advertisement instance, and in the JavaScript, a very easy function which creates the pre-roll, mid-roll, and post-roll positions. So when my video player begins, it will download the XML file for the pre-roll and begin to show the advertisement. And in the mid-roll, after 10 seconds, it will show a mid-roll. And all the definitions are coming from the cloud. So this is my pre-roll and my main content. And 10 seconds later, my mid-roll. As you see, it is very easy to monetize your content with the player framework. Just a couple of lines, XML definition, which ads to show, and when to show. When we look at it, it is very easy. And when we check what is going underneath in the scenes, a typical content owner uploads its content and the advertisement definition to the cloud. And this definition includes when and what to play and maps to VEST XMLs. Then a player developer just get this content and the URLs of the XMLs, build it as player, target it to the clients, and the application downloads the content and the XML and begins to show the advertisement and the main content. At the end, the content owner and the developer makes the money. It is very simple. Couple of lines and the player framework handles the other side and the advertisement. So this is a hot topic. As I mentioned, a couple of adaptive bitrate streaming technologies are ongoing. And MPEG-Dash is the standardization of these technologies. So what is MPEG-Dash? It is a standard way of dynamic streaming over HTTP. So as smooth, your content is sitting in the server as multiple bitrates and represented as virtually two chunks. And there's a definition of which we call manifest, which maps these multi-bit rates to the content. So the Dash client downloads the manifest and begins using the manifest and requests the qualities according to their bandwidth or CPU cycles. Actually, the MPEG-Dash is not announced over media services, but it is in a preview state. So how you can get the MPEG-Dash and use single asset to provide multiple outputs. This is a new feature which we call dynamic packaging. In a traditional encoding world, you upload your content, encode it to multi-bit rates, as we did for the smooth. And then if you want to target it to multiple formats like HLS for iOS devices, you need to repackage it and duplicate the storage cost. So one asset will be HLS, the other asset will be smooth. And if the formats increases, the storage cost and the encoding time will increase. In dynamic packaging, the upload and encode is the same. It is not changing. You upload your content, encode it to multi-bit rates. But the origin server, which includes the dynamic packaging feature, takes care of changing the format on the fly. If you request the HLS format, the dynamic packaging feature will convert the package on the fly to HLS. If you request a smooth format, the dynamic packaging will convert it to smooth format on the fly. So it is very convenient, and it reduces the storage costs, and it allows us to include different formats in feature. So if you want to include Impact Dash, we will be just adding to the dynamic feature as we did today. So right now, you can go and get Impact Dash output over the Windows Azure Media Services. To enable it, you need to enable reserved units. It is coupled with the reserved units. You need to go to the Media Services, enable a reserved unit on the origin site, streaming site, and you will be getting the benefit of dynamic packaging. So I just want to demo the Impact Dash. I will be using my existing smooth asset and show how it will be dynamically converted to Impact Dash. And also show how the Player Framework plugins works. So the Player Framework, the latest version, includes the Impact Dash plugin. You just add it to the references and create an instance of the plugin, and it supports the Impact Dash format. So this is my Dash demo application. As you see, this is the smooth manifest. So I will be using my encoded smooth manifest, and also add this format equals MPT time CSF. This is a indicator to my server that please dynamically package it and convert the time-based MPD, which is the Dash format, the Dash live profile. And when I load this, my server will be converting dynamically the smooth to Impact Dash fragments and the manifest. And the Player Framework Dash plugin is consuming the Dash packages over the cloud. So if you need some extra format support, or if you need to customize the Player Framework, you can use the plugin architecture and build your feature and include it in your applications. So I'm a developer. Where to begin? You just download the Player Framework Smooth Streaming SDK. We have two flavors. One is the Windows 8 version, and the other one is the 8.1. If you want to support DRM encrypted content, you need to get the player-ready SDKs. And a good beginning is the Player Framework sample applications. You can download it. It is open source as well, and you can play with the samples. And if you want to get familiar with the Windows Azure Media Services, you can begin with the Azure, windowsazure.com/media services. And also, if you want to play with the dynamic packaging and Azure services, you can create a free trial account from Azure, windowsazure.com, and also use your MSDN account. I don't know if you are familiar, the MSDN account is converted to MSDN credits. So each month you will be getting some credits to buy features. You can use your MSDN credits to buy the reserved units and play with the dynamic packaging. So some of the application references for Player Framework and smooth streaming. Hulu, Telefonica, Samsung, Fox, France TV are using smooth streaming and Play Ready for their Windows Store applications and for Silverlight. So let's recap. the rich story. We have the web category, Silverlight, Flash, HTML5, applications, Windows Store applications, Xbox applications, TVs, set-top boxes, mobile applications, phone, Android, and iOS. And we covered the Windows Player Framework and the extension today. So it is very easy to build Windows video applications, which is highly customizable and very easy. Player frameworks make it very simple. And Azure Media Services have the ability to upload once, convert it to multiple endpoints. Okay. Any questions? It's okay.
Over the crowd. The stuff that's on Azure right now is we can use it to do everything you just did?
Yes. All the demos you can play to now. Yes. You can get the Impact Dash support, you can get the Smooth, you can get the HLS.
And later on we'll be able to download your sample there, or is similar samples available?
Yeah, the similar samples are available in the player framework page. So you can download the samples here. You can get the extension, the SDK, you can get the samples, and you can get the source code from GitHub. You can enlist the source code from GitHub.
And then Azure lets me download a sample of already with my
Yeah, you can go and create a trial account. Also, you can use your MSDN account if you have and play with the Azure Media Services. It will, I don't remember the exact numbers, but it will give you a file, upload, encode, and stream choices.
What if you need multiple DRM for that?
So currently, we only support PlayReady for Smooth. In future, there is a standardization effort like Impact Dash, which is the common encryption. When common encryption is implemented, it will allow us to consume multiple DRMs. The AES encryption. Actually, it is in our roadmap, but we don't have a clear date right now. In future, we will be supporting. Right now, we are already supporting it for HLS. Any other questions? Please follow our forum. It is in the links. We will be sending announcements in our forums, and also if you can follow our media services page. You want it?
I guess this is the best time to advertise that I work together with Ken, and he has the Monetize media services team. And I'm going to have a session this afternoon, 3:30, to talk about Windows Azure Media Services, specifically all the features on the server side provided in the cloud. So I will be talking about roadmap as well. So regarding all these features, when they will be available, and I will be reviewing live streaming features this afternoon. So if you guys are interested, please come by to the session, and we'll enjoy all the exciting demos later. Okay?
Okay. Any other? Thank you very much for coming and attending. Have a good build.